flat bone, right? Okay. So flat bones use intramembranous ossification. It's not going to take too much longer. Just about 20 more minutes. Maybe less. All right. So intramembranous ossification begins at about a 5-week-old fetus. So you're inside your parents' uterus, right, your mom's uterus, and you're developing. The actual formation of bone begins at about 8 weeks, when they actually technically, when you change from what we call an embryo to a fetus. About 8 weeks of pregnancy. It's completed by the time you're 2 years old. So intramembranous ossification is completely finished by the time you're 2 years old. What kind of bones? The skull bone, flat bone. Also the mandible, your lower jawbone, and the clavicle bones. So pretty much flat bones for the most part. All right, so now I'm going to explain how it works. This is really cool. You start with mesenchyme, mesenchymal cells. Are those a fancy name for stem cells? Yes? Yeah. So those are stem cells, and they form a membrane, a connective tissue membrane, in the shape of the future bone. So how did your skull bone start out? This one, like your parietal bone. Did it start out as just a membrane? Yes. A soft membrane in the shape of the parietal bone. Do you get it? So look at the name of it. From a membrane, inside the membrane, intramembranous ossification. I'm forming bone inside of connective tissue membranes. Are you getting this? Really interesting. So you form a connective tissue membrane in the shape of the future bone, like a skull bone. It's soft, it's not even bone yet. Then, the mesenchymal cells turn into osteoblasts. That's what I meant when I said they're like a precursor to the osteoblast. Yeah, they turn into osteoblasts. Stem cells turn into osteoblasts. Can stem cells become just about any type of cell? Yeah, that's why they're so, sought after. So they become osteoblasts. Now, of course, this is inside the membrane. So the osteoblasts start to produce bone, but they produce spongy bone. Why? Because they're turning into osteoblasts inside the membrane. So are they on the inside of the future bone, where the spongy bone would be? So you end up forming the trabeculae. What's trabeculae? Branches, spongy bone. Branches of bone, right? Trabecular bone. Then, finally, the osteoblasts that are in a connective tissue outer sheath called the periosteum. Remember the periosteum? Those form the compact bone around the spongy bone. So here's my question. What if I asked this on a test? I said, which bone formation process? But no, I'll ask it a different way. Intramembranous ossification forms which part of the bone first? Good. Spongy bone first. Then the compact bone after. So you form the inside of the bone first. Then from the periosteum, because you always keep the periosteum on the outside of a bone. From the periosteum, you take those osteoblasts and you form the compact bone around the blood vessel. Remember, you have perversion canals. Am I connecting this week's information to last week? I really like this summer class so far. You guys are great. Really good. I'd like to see a couple of you, some of you, bring your grade up. You can do it for sure. Your grade's a little bit slow. I want to see it higher than me. You just have to really study a little harder. Okay? But the rest of you are doing wonderful. Good so far. Good class. All right. So we good? Right now, this is what it looks like. You end up making a bone sandwich. Right? Which one formed first, the spongy or the compact?
Spongy.
Spongy, and I like the way the artist drew this, because look, you can really see the way the artist drew this, the way they use shading is really good. They got the spongy bone first, then the compact on both sides, and then what's that little darker yellow on the very outside? That's the periosteum. It stays for the rest of the life of that bone. So you form the spongy bone from the mesenchymal cells that turn into osteoblasts. Then you take the periosteum, which is still there, and the osteoblasts that are there, you form the compact bone around the blood vessels. Isn't that cool? You're speechless. Yeah. Pretty neat, huh? Yeah. That's intramembranous ossification. Flat bones, use it. Yeah.
When you're forming the compact bone, is it possible that they constrict the blood vessels?
No, because they'll grow around them only.
Okay.
And you'll keep that Haversian canal, keep the Volkmann's canal. The canal won't collapse.
Okay.
Yeah. You get it? All right. Okay, now, you guys good so far? Okay, now, there's another method. Now, this is what method would you use to form these bones? Intramembranous ossification. Yeah, do you see that? Little baby, right? An X-ray of their skull. Now, what about a long bone, or a short bone, or an irregular bone? What are they going to use? Intramembranous ossification? No. They're going to use endochondral ossification. So the rest of the bones of your body use endochondral. That means endo means inside. Chondral. Come on, you've heard that before. Cartilage. So inside of cartilage, you make bone. So from cartilage, you're making bone. This is the last thing to teach you. After I teach you this, we're done for the week. Endochondral ossification. Yeah. The rest of the bones, like irregular bones, short bones, long bones, they all use endochondral ossification. Cartilage forms first, in the shape of the future bone, at about 4 weeks. So instead of a membrane, you now have what looks like a bone, but it's made up of cartilage. What kind of cartilage is it? Hyaline. Hyaline cartilage. And then the bone formation starts at about 8 weeks. Just like intramembranous ossification. Turning cartilage into bone starts at about 8 weeks of development of a fetus. What kind of bones? All the rest of the bones. It's completed by the time you're 20 years old. Intramembranous ossification, because it's your skull bones, it's completed by the time you're 2 years old. Why? Because that's when your brain is finally at its full size. It's not functioning like an adult yet, but it's full size. Remember, this is why the head's so big compared to the face on a little baby. Okay, now, it starts with mesenchymal cells. Again, what are those again? Stem cells. They turn into chondroblasts. What's a chondroblast? You've never talked about that, Mr. Beamer. Take a guess. Use that brain of yours. No, chondroblast. Good. I love that. It's the immature form. It's the juvenile form of a chondrocyte. You guys are awesome. You're using your brain like you should be. Do you know that if you keep learning, I told you this, if you keep learning throughout your lifetime, you stop yourself from getting demented. Remember? Dementia. I'm saving you from dementia in this book. Pretty cool. All right. So now, chondroblasts will produce a hyaline cartilage matrix around them in the shape of the future bone. So it looks like a bone, but it's really cartilage. And then the chondroblasts turn into chondrocytes in their lacuna. Is this sounding a lot like what we did with intramembranous, except you're doing it with cartilage first? So you start with mesenchymal cells that turn into chondroblasts. They make cartilage matrix. Remember the protein matrix is cartilage. Get trapped in their lacuna and then turn into chondrocytes. And of course, what shape did they make? Well, it looks exactly like a future bone, like a femur, but it's made of cartilage. So far. Then blood vessels start penetrating the perichondria.